We are given here that two tanks are connected by a valve. One tank contains 2 kilograms of carbon monoxide gas at 77.7 bar, and the other one holds 8 kilograms of the same gas at 1.2 bar. So the valve is opened and our gas are allowed to mix, and there's no insulation and heat is being transferred from the surrounding towards the system. The final equilibrium temperature is at 42 degrees Celsius. So we are being asked here to calculate the final equilibrium pressure and the heat transfer in kilojoules. So let me put here the sketch first so that we'll have a better understanding of the problem. Okay, we have here the two tanks, the one containing 2 kilograms 77, so tank 1 at 0.7 bar, the other one 1.2 bar at 8 kilograms, containing 8 kilograms of carbon monoxide at 27. So I think almost everything are given, like the pressure, temperature, the amount. So I hope that through that we can solve for actually the volume of tank 1, right? Volume of tank 1, and also we can solve for the volume of tank 2 because we already given with everything. If we use the ideal gas equation, then we can simply solve for that, right? I think that it will not be really be a problem how to solve for the volume. But what will happen if after you open this valve, the carbon monoxide will allow to what? This 1.2 bar will allow to flow to the other side, and things will then be uh, things will then be equal for the two tanks. Like at equilibrium, whatever pressure and temperature at tank 1 will be the same with that of tank 2 because they are now at equilibrium. Essentially, after the process, we'll then be having the pressure here will be the same for the two tanks, also with the temperature of the two tanks. Of course, the amount will not be the same because you can see more or less this will be a bigger tank than that. But they will have a mechanical and thermal equilibrium. Thermal equilibrium means that temperature here and temperature here will just be the same. Pressure at the left side of the tank to the right will be also the same. And our first task is to calculate for the final, I think we're given final temp, right? The final equilibrium temp is 42, which means this will be 42 degrees Celsius and this will also be 42 degrees Celsius. Okay, they'll only be asking now to calculate for the final pressure. But before we can do that, I believe we need to look first for the volume of the tank 1 and volume of the tank 2. And because this case, this even if it seems like you have two tanks all together, you can just actually think of that as a single tank, really, single tank, which now contains 10 kilogram of carbon monoxide, which the temperature is now at 42, and then now the pressure is equal to what we're looking for, and the volume of the tank will just be equal to the volume of this tank will just be equal to volume of tank 1 plus volume of tank 2. So at equilibrium, one can really solve for P once we know VT1 and VT2. How do we solve for that again? Well, using the ideal gas law, right? We have PV is equal to nRT, and to solve for V, it's just then equal to nRT over P. Okay, here we are given with mass, but how do you convert this to number of moles? Well, we have molecular weight of CO. Well, see, carbon is 12, oxygen is 16, so therefore we'll have here 28 gram per mole. One could simply convert the mass, given mass, into moles. Okay, like 2 kilogram is equivalent to 2000 grams. Divide that by 28. Therefore, this one will just be 71. The 2 kilogram mass will just be equivalent to 71.43 moles. And the other one, the 8 kilogram, that's 8000 grams divided by 28, it will give us a 285.71 moles. Okay, and how to get the volume? So now if we solve for volume of tank 1, we'll just be having that N, which is 71.43 moles. Okay, R will be 8.3145 joule per mole Kelvin. Temp is 77. plus 273.15. That's conversion. 77 plus 273.15. That gives us 350.15 Kelvin. So be sure to put things in Kelvin. And the pressure is zero point 0.7 bar. That's 70,000. That's 70,000 Pascal. Note, use standard SI unit, so pressure must be in Pascal, temperature in Kelvin. And this will then lead us to a volume of tank 1 equal 2.97 m cube. Okay, volume of tank 1 is equal to 2.97 m cube. And similarly for tank 2, using no, the only difference is that we'll only be having 285.71 for the moles times 8.3145 times this one. The temperature of tank 2 is 27 plus 273.15, okay, divided by the pressure of tank 2, that's 120,000 Pascal, right? That's 1.2 bar. And it gives us a volume for tank 2 equal to 5.94 m cube. Essentially, now we know that the volume when this tank are in equilibrium, now we open the valve, it seems like the tank now has been combined together. They will have a total volume of 5.94 plus 2.97, that gives us a total volume of 8.91 m cube. Okay, and then same, because the amount will just be the sum of the 2 kilogram, the 8 kilogram. So equivalent moles for this will be, or you can just simply have 10,000 divided by 28. That's equivalent to 357. Okay, 0.14. Okay, 357.4, or you can simply add the moles there. This is in terms of moles, and we have now the volume. So the pressure, okay, pressure, the final pressure, let's call that PF. The final pressure after equilibrium will just be equal to N, that's 357.14. R will be 8. Oh no, to solve for pressure, that's nRT over V, right? nRT divided by V, so 8.3145, and then T is known, 42. 42 plus 273.15, that gives us 315.15. 315.15 over the volume. So the volume total will be 8.91 m cube. Therefore, the pressure will be 105,030 Pascal, or I divide that by 100,000. It will then be equivalent to 1.05 bar. Okay, the final pressure, when they combine, it becomes 1.05 bar. That's the answer to our first question. What will be the equilibrium pressure in bar? Now our second question is, we're looking for the heat transfer in kilojoules, because as it's being stated here, this tank is not insulated, and during the process, heat is entering from the surrounding. Perhaps the surrounding is hotter, surrounding is adding heat to your system, and we are being asked to calculate for that. So how do we calculate for that? So now let's look for the heat. Now we always refer to, this is a closed system, right? If we think as the whole tank as our system, the two tanks, it's a closed system. No, but nothing leaks to the surrounding. Okay, so in this case, we essentially can use the equation delta U is equal to Q plus W, right? Delta U is equal to Q plus W. And since there's no there's no work, because there's no expansion work, there's no shaft, there's no electrical power input. So this will be 0 because the tank is rigid, so it's not doing work to the surrounding also. And therefore, Q will just be equal to delta U. So how do we solve for, to solve for Q, we must know delta U for this. Now, as you can see from here, essentially, yung tank 1 mo, from 77, nagiging 42. So, yung nag-ano lang siya, nagbaba yung temp. 77, nagiging 42. Yung isang tank mo rin, from 27 nagiging 42 rin. Parang gano'n yung nangyari sa tank mo. And essentially, in this case, one can solve for, well, the delta U will just be change in the internal energy of your carbon dioxide, right? And you can think of it as if this 2 kilogram, becomes carbon dioxide from 77 to 42, and the other one from 27 nagiging 42. Okay? And how do you solve for that? Well, in this case now, delta U will just be equal to delta U1 plus delta U2. Essentially, ito yung mass mo na 2 kilogram yung isa. Okay? Now, how do we solve for delta U? Well, delta U will just be N, number of moles, times CV times delta T. Okay? This will be it for an ideal gas. Essentially, because CV is constant. Also for the other one, like we'll have the N1, CV1. We'll have for the other gas N2, CV2, delta T2. Okay? And what do you mean by that delta T? Well, essentially, number of moles, yung first number of moles mo will be like 2 kilograms, that's 71.43. You can think of it as it what? 71.43. By the way, what is CV? CV for an ideal gas is essentially equal to, well, this diatomic carbon monoxide, it's equal to what? 5 halves R. So CV for an ideal gas is 5 halves R, and we know R, of course. Okay, so we'll have here, this is in moles, so I just dropped the unit. I'm confident that I know the units for this. So 5 halves R. Okay, mamaya na yung R. And delta T1 will be thinking that as if yung 2 kilograms mo from 77 nagiging 42. Okay, so that's what? Delta T will be 42 minus 77. Okay, how about delta T2? Well, yung 285.71 moles mo plus 285.71 moles, okay, times 5 halves R, times the final temp is 42 and its initial temp is 27. So you can see it's not a function of the pressure. The internal energy is not a function of a pressure for an ideal gas. And this will lead to delta U. Okay, the sum of that will just be equal to, it's equal to 7294.85 R. 7294.85 R, and knowing that R is 8.3145, this will then just be equal to times 8.3145. It will just be equal to 60653. Okay, 60653. Okay, 60. But that the unit for this will be joule. This is moles. This will be joule per mole, Kelvin, and this will be um. So that will be joule. So I divide it by 1,000 to make it in kilojoule. I think I'm being asked for a kilojoule. This will then be equal to 60.7 kilojoule. Okay, 60.7 kilojoule. So delta U is equal to that, 60.7 kilojoule, and that is supposed to be equal to Q, meaning the heat that flows from the surrounding to your system is equal to this 60.7 kilojoules. So the thing here is we solve delta U by using the ideal gas equation for delta U, NCV delta T, but we assume that there are two masses or two moles, two sets of mass from 77 naging 42, yung isa from 27 naging 42. So, inaisa-isa natin kasi nga iba-iba kasi yung initial condition nila. But wait, I think as I go through the review of this is not supposed to give me 7 to. So I think this is a mistake. No, when you try to evaluate this one, multiply everything. Okay, put R to be 8.3145. You will not be getting 60.7 kilojoules, but supposed to be you'll be getting 37.1. Okay, you're supposed to be getting here 37.1 kilojoule the instead of the 16. Okay, so it's just a mistake on the implementation of these numbers in the calculator. So I made a mistake for that. But essentially, this is the answer. Thank you.